I would now like to introduce you to our presenter today, Bill Evans, and he is the Senior Product Manager at WD. We also have Britton Spaniola on the line to make sure all your questions get answered, and she is the Senior Programs Manager at WD. Bill, whenever you're ready, go ahead and take it away.
Thanks, Abby. Good morning, everybody. My name is Bill Evans, and I am an employee of Western Digital, based in our offices in beautiful Mountain View, California. Today, I want to share with you some insights about how to back up and recover virtualized environments. But before I begin, I want to remind you that not only is Western Digital the world's largest manufacturer of hard disk drives and a major provider of consumer direct attached storage and network attached storage, we also have a line of products for small and medium businesses. The products for small and medium businesses include network attached storage and network backup appliances and software. And today we'll be talking about the network backup appliances and software. Just today, though, Western Digital announced our first rack-mounted NAS in a 1U form factor. It's called the RX4100. You can get more information about this rack-mounted NAS at WD.com. WD expanded into network backup products for SMBs with the acquisition of Archaea Software at the end of last year. The agenda for today's webinar is shown up on your screen. I want to provide some history and background on volume and file backups and history and background on virtualization in general, discuss strategies for backing up virtualized environments, talk about what's possible with different hypervisors because some hypervisors give you more options than other hypervisors. The standards are not yet fully firm in the industry. I want to talk to you about issues around getting backups off-site. WD believes that you don't have a backup you can depend upon until you have a backup that is safely stored off-site. In California, we say your backup must be at least one earthquake fault away. I also want to discuss some of the pros and cons of backing up physical and virtual machines with integrated systems or separate solutions, and then talk about the deployment of backup servers as virtual appliances. So let's get started. Virtualization has been with us for quite a while. Many of you are probably aware that there are several kinds of virtualization out there. Hardware virtualization was first introduced when my father was a young man on the IBM VM370 product. It's been introduced more recently in products from VMware like ESXi and from Microsoft like Hyper-V, but it's been with us for a long time, the concept. Operating system virtualization is standard today in most operating systems. Both Unix and Windows provide support for virtualization. Windows' very first release based on MS-DOS a long time ago did not have virtualization, but subsequent implementations of Windows, starting with NT, did support virtualization. And you can even get virtualization at the application level, independent of the operating system. This is true of languages like Java and Smalltalk, which was the precursor to Java. The motivation for hardware virtualization was really simple at the beginning. Hardware was very, very expensive. And in order to make more efficient use of your machine, you wanted multiple users to be able to work independently on that machine. That was one of the original rationales for the introduction of the VMware products many years ago. But more recently, we've seen a lot of other uses of virtualization. It makes possible to change the environment that you're working in to spin up new applications as virtual appliances very quickly. The flexibility of virtualization certainly surpasses the flexibility of servers and cables and networking systems. And a further motivation for hardware virtualization is that the hardware guys have been very successful in building very powerful machines that today largely provide more resources than a single application would need. Yet because of hardware virtualization, we're now able to deliver virtual machines that are fully separated one from another to an extent that most operating systems do not allow. Backup can be done at many different levels of the information technology infrastructure in your environments. The most common level at which backup has been done historically is at the file level. An application talks to a file system by specifying a file name and a file length, and the backups typically are done of the entire file. Backing up a file system consists of walking the metadata that compose the file system directories, learning what files are there and backing them up one after another. Now, file systems themselves are built on top of volumes. Rather than backing up a file system, you can back up the volume on which the file system is written. In this case, because each block in a volume has its own block number, you would back up one block after another. You could go still one level deeper if you wanted and back up physical media based on head, cylinder, and sector, but virtually all backups today are done either at the file grain or at the volume grain. File grain were the most common form of backups until the advent of virtualization, and now the standard for virtualization is to back up at a volume level rather than at the file system level. Let's discuss some of the pros and cons of backing up systems at these different levels. When you're backing up a file system at the file level and you have a set of files, some previously backed up, some not, and you specify a full backup, what happens is you, again, walk the file tree and you back up one file after another. And all of these files are moved, sometimes slowly, to your backup server target storage. So the source data you're trying to protect is on the right, and the target storage to which you're writing your backups is on the left. After you back up a full file system, all the files, you're able to subsequently back up an individual file that is changed. In this case, we backed up a very small file with a small change, and that went pretty quickly because the file was small. If you make a small change to a large file and you're doing file grain incrementals, you have to back up that whole file. So if you have a multi-gigabyte file and you've made just one small change to it, like an outlook.pst, it can still take a lot of time to back up that file. By comparison, if you're doing volume backups, you have the option to do what are called block grain incrementals. The first full backup of a volume backup consists of taking all of the used blocks on the volume and moving it to the target storage. But then when changes are made to an individual file, in the case of a small file, only the block that's been changed has to be backed up. In the case of a large file, similarly, only the block that has been changed has to be backed up. So the attraction of using block grain incrementals made possible in volume backups is that your incremental backups can generally be much smaller and much faster regardless of the size of the underlying files. So for virtualization, we similarly have these two options. At the very beginning in virtualization, all backups were done with agents in the guest operating systems. These were file system backups with traditional file grain incrementals. Then more recently, the hypervisor vendors made it possible for us to access the full volume that constituted the disk image of the virtual machine. So the backup vendors started doing volume backups of the image of the virtual machine. And the best hypervisor vendors made possible block grain incrementals. As an aside, you might think, why haven't we in the industry done block grain backups for files? Well, we have, but it requires the participation of the file system writer. So if you've written a file system, you can make known to a backup server the blocks that have changed, but very few file systems do this. One of the first file systems to support block grain incremental backup of files came from Veritas, but it never caught on as a mainstream file system. So today there are effectively 3 different strategies for backing up virtualized environments. The first strategy is to put a backup agent on each guest operating system on a hypervisor. The second strategy is to put an agent on the hypervisor itself and use that hypervisor agent to back up all the virtual machines. The first backup is a file grain backup. The second backup is an image or volume grain backup. The third option, made possible by some hypervisors, is simply to talk a specific protocol to the hypervisor and back up the entire image. The first company to provide facilities like this was VMware in ESX 3.0, about 3 years ago. And VMware provided to the backup vendors a set of APIs known as the vStorage APIs for data protection, or VADP. These APIs made it possible for the backup servers to talk directly to the hypervisor, making what are called agentless backups possible. So the pros and cons of image backups are important to understand. It's certain that image backups are the popular way to back up virtual machines, but they're not in all cases the right way for you to back up a virtual machine. The pros are very obvious. Because some hypervisors provide for changed block tracking, once you do a full image backup, incremental backups can be very, very fast. This is a huge win for many organizations, and that's enough of a reason to do an image backup. The other big pro, probably just as valuable, is if time to recovery is very important to you, then being able to recover an image is going to give you faster recovery than recovering individual files. So accelerating disaster recovery, or in a way failing over to another hypervisor, is one of the benefits of image backups. The pros are fairly well understood because those have been broadly promoted in the industry. By comparison, there are some cons to image backups. Image backups can be slower than file backups in the case that you're only backing up a few particular files. There's no reason to back up the entire image if all you need are specific files. I know a number of our customers that use image backups for some virtual machines and use backup agents to back up files in other virtual machines. Another con of image backups is they can often generate very large backup files. Now, the size of the backup file is going to be reduced due to compression and deduplication. It's also going to be reduced because of changed block tracking and its ability to deliver small incremental backups. But the size of the file to be backed up nonetheless is going to be larger than if you're backing up only the individual files inside the virtual machine that you care about. The third issue is not discussed as much as it should be. This is a very important issue because it talks to the reliability of your backups. When you do an image backup, if you're not careful about how you arrange your machines, it's possible to have a backup set that has not been made consistent. If you have, for example, applications or databases that are running at the time you do an image backup, you will get what is described as a crash-consistent backup, a backup that's only as good as it would be if you unplugged the power to the physical machine. So when you do an image backup, you want to be certain, to the extent possible, that your applications and databases have been appropriately quiesced, so that all of the state information in memory has been moved to the physical disk, so that when you back up that disk image, you're getting a consistent set of data right up to the very moment of the backup, to the moment that you've quiesced those applications. Some mitigating factors when you're talking about image backups have to do with the impact that deduplication has on reducing volume size. If you have one virtual machine and one virtual machine only that you're backing up, a large fraction of that backup is going to consist of the operating system and associated files. You can compress this data, but you still have to carry it with you in the volume. On the other hand, when you have multiple virtual machines, and these multiple virtual machines are all being backed up with image backups in parallel, deduplication will cause you to retain only one set of the files common across those virtual machines. That one set of files that is typically the operating system. Another benefit of deduplication in this context is that the blocks that are managed by the hypervisor to do incremental backups, these changed blocks, these are almost always at a much larger grain than the dedupe block. So if a changed block is on the order of single-digit megabytes, you're going to be given a full megabyte or two to put on disk as the backup image for that incremental backup. But if before you put the data on disk, you do deduplication of the block, all of the blocks that were common to previous backups, even previous incremental backups, these will be deduped away, and you'll only be maintaining on disk the deduplication grain block that is different from your previous backup. So deduplication is going to shrink the volume that you need, both for full backups and for incremental backups. And deduplication will also speed up backups because the amount of data that you're writing is smaller. The one thing deduplication won't give you is that because the full changed block has to be moved from the hypervisor to the agent before the deduplication takes place, the amount of network bandwidth you need to do an incremental backup will not be improved by the use of deduplication technology. It's important to recognize that the mechanisms for backing up virtual environments have evolved dramatically over the last 5 or 6 years. In the very beginning, you could always back up every virtual machine using file backup agents. You'd put a backup agent in each guest operating system, and you could always back up the files or applications or databases. It was only subsequently that the hypervisor vendors started offering image backups. VMware's first step was to make it possible to put a backup agent on the hypervisor. These were called console backups. And when you put a backup agent on the hypervisor, the backup agent would talk to the hypervisor to get consistent images of all of your virtual machines. Subsequently, VMware didn't want third-party software running on their hypervisors, and their early hypervisors were based on Red Hat Linux. So VMware disallowed console backups, but made possible backups using a proxy server. This is what VMware called VCB, or VMware Consolidated Backup. Subsequently, VCB morphed into what we know today as the vStorage APIs for data protection. So the vStorage APIs for data protection allow a backup server to talk over the network, a protocol, to the hypervisor, to the VMware hypervisor, and to retrieve from the hypervisor both full and differential and incremental backups of each virtual machine. So the standard today for VMware is agentless backups. The backups are called agentless. The reason they're called agentless is because the backup server and agent can be bundled on the same machine, and that machine then talks directly to the hypervisor to get images of each virtual machine volume. So companies that offer agentless backups are companies that use VADP, and every backup vendor that I'm familiar with today offers only agentless backups of VMware hypervisors. Now, VMware is just one of a whole series of different virtualization vendors whose products are available today. VMware has done very well, but the others are not to be underestimated. Today, we're on VMware 5. I believe it's 5.1. VMware lets you do either image or file backups. The image backups are done agentless, and they can be full, differential, or incremental. By comparison, Hyper-V, they'll also let you do full or, that is, they'll let you do image or file backups, but they'll only let you do console image backups that are full. Zen Server, again, file or image, console, and full. Red Hat Enterprise Linux 3.1 will still only let you do file. They won't let you do image backups. They require a file backup agent on each guest operating system. But in that case, they can do full, differential, and incremental backups of those files. Parallels Cloud Server 6 will let you do image or file. They don't offer an API, though, so you need scripts to generate the image backup, which is stored to a file, which is subsequently backed up. And these are image backups that are full. The fact that these different vendors provide different mechanisms for backup, and each vendor is on its own trajectory of improving the backup process, is indicative of a category where we're seeing a lot of change. Virtualization has really been expanding tremendously in its impact over the last few years, and the approaches that we see for backup today are obviously very different than they were 5 years ago, and we can be confident that in 5 years' time they're going to be still very different from the way they are today. Now let's talk a little bit about how to get a backup off-site. As I said at the outset, you don't have a backup that you can have confidence in until you have a backup that's off-site. Traditionally, there have been 3 alternatives to getting backups off-site. The first alternative has been to write backups to media, typically tape, and then ship them off-site on a truck. The majority of IT shops in the world today use tapes on trucks to get their data off-site. It's only been with the advent of cheap WAN connectivity that companies have been able to move data off-site over the wide area network. Cloud backup is one of those techniques. In cloud backup, you would put a backup agent on each machine that needs to be protected, and that backup agent would push data directly to the cloud. With hybrid cloud backups, you would do a backup to a local backup server and then replicate that backup to the cloud. In the case of cloud backup, the server in the cloud is always multi-tenant. That is, it's a public cloud. In the case of hybrid cloud backup, the server in the cloud can be either private or multi-tenant or public. We see most small and medium businesses adopting hybrid cloud backup using private clouds, and we can talk more about this later. So how do you choose among these options? The most obvious way to choose is based on costs, both fixed and variable. Other issues that are critical are the length of the backup window, where shorter is better, and time to restore, where shorter is better. Softer criteria are reliability and convenience, but these can be important as well. If we grade each of these three criteria on fixed costs, variable costs, length of the backup window, and time to restore, there are two clear winners. These are tapes on trucks and hybrid cloud backup. Tapes on trucks is still a great alternative today because while the fixed costs of backups are high, the variable costs are very low. Because your backups are being maintained on a local backup server, the backup window is short. And because your backups are being maintained on that local backup server, your time to restore is short. The biggest objection to tapes on trucks are the high fixed costs. Fixed costs are high because you need a truck to come to your offices every day. That costs money. And because you need to have typically a tape library in the case that your backups require more than one tape. So a tape library would manage a dozen or 100 or 1,000 tapes and deliver up the tapes necessary to be written. They would be written typically overnight. The next morning the tapes are collected and given to the guy on the truck. By comparison, cloud backup has little good to say for it. Cloud backup has low fixed costs. You simply have to install a backup agent on your servers. But the variable costs are very high because the cost of bandwidth can be substantial. The backup window is long because the time to do a full backup or even an incremental backup can be fairly long, and the backup window has to be open that entire time. The time to restore can be long for the same reason. Hybrid cloud backup is a big improvement on cloud backup because the backup windows and time to restores can be kept short because you have a local copy of the data. So over a backup window of perhaps an hour at night, you might back up all of your systems, and then you would replicate a copy of those backups to the cloud. Again, it could be either private cloud or public cloud. The big expense in hybrid cloud backup is simply the variable cost of the network bandwidth. Hybrid cloud backup, like cloud backup, has become popular as the cost of internet bandwidth has declined. But it's still the cost of that bandwidth that is the long pole in the tent on the adoption of hybrid cloud backups. So in choosing between the two best alternatives, tape or hybrid cloud, you're going to have to run some calculations to understand the costs of tape drives, autoloaders, or libraries. And you're going to have to be certain that your backup server solution is able to manage backups of virtual or non-virtual environments directly to tape or to disk and then to tape. Disk to tape, D to T, was popular many years ago, but has more recently largely been replaced by backups that are staged first to disk and then replicated to tape. The large number of people who continue to use tape as the mechanism for getting their backups off-site reflects the fact that tape continues to be very cost-effective. It's not very fashionable. We see many fewer new customers deploying a tape solution, but the people deploying tape has not dropped to zero. Tape is still cost-effective for environments with large volumes of data. So we encourage you to consider this as an alternative. The second alternative, hybrid cloud backup, is much more fashionable, and we see a lot of people moving in this direction to get their backups off-site. The things to be aware of is that some big tasks like moving the first backup off-site or restoring a backup from a remote location, these require much more bandwidth than moving a nightly incremental backup off-site or restoring a single file from off-site. So you have big bandwidth events and small bandwidth events. The small bandwidth events can be performed with a WAN transfer. That's easy. The big events require a little bit more consideration. You don't want to size your network bandwidth for the big events. One solution that WD Archaea proposes is you use techniques like seed and feed. You export a backup to portable media. You ship the portable media, say via FedEx, to a remote location, and then you import the data at the remote location onto your storage target. Seed and feed can be very cost effective because it allows you, with a sufficiently large disk array, effectively 1 gigabit per second of bandwidth with no provisioning costs. If you have a 10 terabyte disk array, you export data to it, you ship it overnight via FedEx. When it arrives, you've effectively enjoyed 24 hours of 1 gigabit per second bandwidth. Another issue that's important to consider when you're backing up virtual environments is, do you want one solution for your virtual environments and a different solution for your physical environments, or do you want one solution for both? This has been an issue that people have addressed forever. Today, the divide is between backups of virtual systems and physical systems. 10 years ago, the divide was between Windows systems and Linux or Unix or mainframe, Unix or mainframe systems. 20 years ago, it was still a different divide between Unix and mainframe systems. So you probably today, in dealing with virtualized environments, are dealing with simply the latest in the many wrinkles that you will see thrown at you by the IT industries that make backup difficult. It's clear that everybody would prefer to have a single backup solution. A single backup solution is easier to manage. It will simplify the whole backup process. It makes dealing with these new ways of technology much easier, because rather than having one system for physical and then moving to a separate system for virtual and managing two systems in the meantime, you're able to manage one system for all your physical and your virtual during the transition, and then all of your virtual at the end. Most of the mainstream vendors, in fact all of the mainstream vendors in backup today, support both physical and virtual environments. It's true that the mainstream vendors were a little bit later than some startups in producing products that could protect virtual environments, but those differences have largely disappeared. It's important when you choose a backup solution that you choose a vendor that's able to deal not just with past wrinkles, but future wrinkles, future changes to your IT environment that are certain to come as new technologies are introduced. It's a lot more work to manage multiple backup solutions than a single backup solution. That was the reason why at the very outset we asked the question about how many different backup solutions do you have. 5 years ago, the answer was almost universally one system with a few people adding a second. A couple of years ago, most people had multiple systems, one for physical, one for virtual, and now we're seeing a decline where people are deciding that managing two backup systems is more trouble than it's worth. Another subject relevant to the use of virtual environments is a decision that you may have to make about whether you want to deploy your backup server as a virtual appliance. If you're embracing virtualization to provide more efficient use of hardware resources, then your backup server should be like any other server. You can deploy it on a virtual environment and have it use resources when it's running and have it not use resources when it's not. So the big pro to deploying a backup server on a virtual machine, to deploying a backup server as a virtual appliance, is that you can eliminate hardware that would otherwise be only lightly used. Backup servers are used very intensely, but typically not 24 hours a day, typically only during short backup periods. Another advantage to deploying a virtual appliance is that you get all the benefit that other virtual machines get from a virtualized infrastructure. In the case of hardware failure, the backup server can be migrated to another physical server. You're able to run regular maintenance on the machine on which the backup server is running because of this migration capability. And it's also much easier and faster to deploy a virtual appliance than it is to deploy either a physical appliance, let alone a software application running on an operating system, running on a new piece of hardware. So there's a lot to be said for running a backup server as a virtual appliance. A couple of the cons are running backup servers, particularly those with dedupe, like WD Archaea, can be very hardware intensive. So if during your backup window you don't have good hardware availability, that is your other applications are not being very lightly used, it may make more sense to have dedicated hardware for your backup server. And then some administrators are philosophically opposed to using shared equipment for the backups. Some administrators prefer that their backup servers be as highly isolated as possible, as just another mechanism to make certain that their backups are solid and will be there when they're needed. So let me give you an example in this slide of backups that are done of virtual environments using a backup server that's deployed as a virtual appliance. So if you have a local area network with storage and a VMware hypervisor running on an x86 architecture, you can deploy a WD Archaea virtual appliance. This will be your backup server running in its own virtual machine on a hypervisor. If you do a backup of other virtual machines on that hypervisor, the WD virtual appliance will cause those backups to be written to target storage. It's also possible with this one virtual appliance to protect other hypervisors. So if you had a second hypervisor, or third or fourth, on your local area network, the WD Archaea virtual appliance would talk to the other VMware hypervisors and do backups to target disk. You can have any number of hypervisors, of course, and this would constitute the virtual part of your infrastructure. But you could also have a physical infrastructure on the same local area network where various kinds of hardware, not necessarily x86, but various kinds of hardware would be running various operating systems. It could be Linux, could be Windows, could be AIX, HPUX, BSD, Solaris. Any operating system would then run a WD Archaea backup agent, and the same backup server would communicate with that backup agent to protect and write to target storage the data on that machine. Whether you deploy your WD Archaea backup server as a virtual appliance, as a physical appliance, or as a software application, you can protect in a single backup job any combination of virtual machines on any number of different kinds of hypervisors, as well as files, application, and database data on any number of physical machines. Now, the sponsors of this webinar have insisted that I spend a couple slides to give you background on WD's network backup solution called WD Archaea. As a preamble, WD is the world's largest manufacturer of hard drives. We have revenue today of $15 billion, almost 100,000 employees, 6,000 active patents, and we spend over $1 billion annually in R&D. To accelerate the delivery of a network product, WD acquired Archaea software last year. The Archaea product delivers backup servers and backup agents. The backup servers are available as appliances with between 2 and 24 terabytes of storage, as virtual appliances, as we've just discussed, and as software applications. Those are the backup servers. We protect platforms with backup agents. We have backup agents for VMware, Hyper-V, and Zen Server. VMware in particular is termed agentless because the backup agent runs on the same platform as the backup server. Other platforms that we protect are the whole slew of Windows, Linux, Mac, and Unix platforms. Some technologies that are Archaea's claim to fame include patented progressive deduplication technology, superior in speed and compression to both fixed and variable block backup deduplication. We provide multi-flow technology. That means that the backup server doesn't back up one machine at a time, but the backup server backs up several machines at a time. This guarantees that a slow client will not be the bottleneck in your backup, because we'll be backing up other clients, other servers on your network at the same time. And we do backups, of course, to disk. We do backups to tape, from disk to tape to cloud, from disk to cloud, pretty much any combination that makes sense for your business requirements. The WD Archaea products are sold exclusively through channel partners worldwide. We have over 100,000 customers in 100 countries. The user interfaces to the product include both a command line interface and a web user interface. One screenshot of the web user interface is shown on the upper right. In the lower right are examples of our 2U appliances. And then for my final slide, let me give you a quick review of our architecture. We have a classic network backup architecture. A backup server is managed either by that graphical web user interface you saw or by a command line interface. The backup server manages backup agents. These backup agents protect various servers or other machines that have data to be protected, including virtualized environments. The data from these machines are written by the backup server to storage devices, whether disk or tape or cloud. If you have pretty much any tape device known to man, we can support it as a destination. We can support disk storage that is file or block. We support cloud storage that is public or private. If you have multiple backup servers, we're able to manage these multiple backup servers from the same web and command line interfaces. You can replicate backup sets from one backup server to another. This is how we do replication between sites and from your local area network to, say, a cloud environment. As I mentioned earlier, the backup servers are available today as software applications. That's where we got our start, and we support 130 different Linux platforms for our backup servers. Our backup servers are also deployed as appliances with capacities ranging from 2 to 24 terabytes of raw disk. Some of our appliances include embedded tape drives. And then, as you saw earlier, our backup servers can be deployed as a virtual appliance on a VMware ESX hypervisor. The backup agents that we support backup files. They run on operating systems, and today we support over 200 different platforms, various versions of Linux, Windows, Macintosh, Unix, Novell, and BSD operating systems. We also provide specialized backup agents. These are backup agents designed to guarantee consistent backups of database servers, applications, and directory servers. So we have specialized agents that talk to, for example, Microsoft SQL Server or Oracle or MySQL or DB2 that use APIs provided by these vendors to let us negotiate with the database management system a consistent backup of the data so that it's not crash consistent, but totally consistent for a clean restore. We do the same thing with APIs provided by application vendors like Microsoft for SharePoint and Exchange and for directory servers. Additional specialized agents include our specialized agent for VMware and Hyper-V. We talked about those briefly in this webinar. And then finally, we have agent-side features like deduplication, encryption, and bare metal disaster recovery. It's the combination of our ease of use through our web user interface, our broad support for backup server deployments, as well as our very broad support for agents and machine protection that have caused us to be the backup solution of choice. So with that final note, let me thank you for your time and pass the webinar control back to Britton Spagnola. Britton?
Thanks, Bill. We had some great questions come in during the presentation, so I'll start off with question number 1. Is hybrid cloud the most secure way of doing backups? And if our network is within an MPLS network, will normal cloud backups be secure enough?
Okay. The security of backups is a little, backups sent to the cloud is a little bit different from the question of security of other applications in the cloud. If you think of applications like Salesforce.com or any other application as a service, your data have to live in the cloud unencrypted because you need to be able to access this data from any number of web browsers. So your data live in the cloud unencrypted. By comparison, when you do hybrid cloud backup, your data should live in the cloud fully encrypted. And they can live in the cloud encrypted in 2 different ways. One way is that the metadata that contains the file names and file sizes and file permissions, this information can be unencrypted and the file data itself can be encrypted. This allows you to restore single files from the cloud. Another option is that everything in the cloud be encrypted so that you can't restore individual files, but you're able to do recoveries of full systems. So the mechanism by which you implement your network, whether it's a wireline system or a wireless system, plays very little role in terms of the privacy of your data. You certainly want a network that will provide you with consistent connectivity, otherwise your backups will not take place and your recovery cannot happen. But so long as your network infrastructure, your IP infrastructure is solid, the privacy of your data is guaranteed by encryption, not by any mechanism in the network or TCP backbone.
Okay, next question. Is VMware just ahead of the competition in regards to backups?
VMware got an early start in the category, and still today I would say that they're probably a little bit ahead of the competition. But having spoken with the competition as well as with VMware, the competition is working very hard to deliver similar mechanisms comparable to changed block tracking that VMware introduced a couple of versions ago. VMware has done an excellent job. There's some obvious laggards in the virtualization space, but I think it's too early to count anybody out. Virtualization is with us today. It's here to stay, and I'm confident that the vendors that don't have the most sophisticated mechanisms for fast backups and recoveries are going to be working to deliver those mechanisms.
Okay, a couple more questions. Why would you ever want to back up VMs to tape? Isn't that dumb?
Backing up it's certain that backing up to tape is no longer fashionable, and that given his druthers, almost everyone would prefer to back up to disk. The big attraction to backing up to disk is that you don't have to read a whole tape in order to find just one block or a handful of blocks that you want to restore. Another reason to back up a related reason to back up to disk and not to tape is that disk is much more deduplication friendly, just because a single file might be distributed across multiple blocks that could be stored on multiple tapes. With disk storage, you don't have that problem. So everything being equal, people would prefer to back up to disk. But the fact of the matter is, if you have a sharp pencil and you do the analysis of what it costs to protect 20 terabytes of data on tape versus 20 terabytes of data on disk, and you factor in the frequency of restores that you need to do, and you factor in the cost of keeping those disks spinning and the cost of the truck and the tape drive, you might be very surprised by how much less expensive tape is for large volumes of data than for disk. And when I say large volumes of data, I'm thinking data more than a terabyte, sometimes more than half a terabyte. It depends on the cost of your bandwidth, and then it depends on the cost of the tape infrastructure. So is it dumb to back up virtual machines to tape? We have customers, most of our customers back up to disk, but we have a lot of customers that still back up to tape just because it's so cost effective as a mechanism to get backups off-site.
Okay, next question. Does this backup solution discussed work well for a DR site? And if so, how close to real-time syncing can you get? Also, would the recommended configuration be to have appliances over software in this case?
That's an excellent question. The trade-off between, I'll take the questions in reverse order. The trade-off between using appliances or using software doesn't really depend on the backup frequency or your strategy for recovery. We see that most of our customers still use our backup server as a software application. That takes a little bit more time to deploy, but the attraction of that is they can deploy it on a machine that perfectly fits their requirements. The trend, though, in the industry is moving from software applications to appliances, and we see a more rapid growth of physical appliances than virtual appliances. But however your backup server is deployed, you can achieve any backup frequency that you want. The question about real-time backups and recovery, again, is orthogonal. You can do backups of virtualized systems at any frequency that you want. Most of our customers do backups on a daily basis rather than on a finer grain basis. There are mechanisms in most databases to accommodate hardware failure. These are database logs that can be rerun to minimize the amount of data you lose if a machine goes bad, but if the disks are maintained. So if you have a RAID backbone, if you have RAID storage infrastructure on your machines, and one disk drive fails, your data should still be protected. If you lose your server, you're able to replace that hardware and your data should still be available. Having the data off-site on a real-time, maintaining a backup on a real-time basis is almost not backup. Having a synchronous replica of your data is a special case of backup that we don't see very much. You can certainly do this without backup software by having a second machine and using hardware synchronization of the two disks. Generally, that will slow down your primary systems, and so we don't see it done very much. It's talked about a lot, but it's not done very much. If you want to have dual systems that can provide immediate failover, the better way to get that is probably through hardware synchronization of data than it is through pushing backups periodically off-site. The other facet to consider when you're looking at rapid recovery is how do you store the images at your target site. So if you do cloud backup, you do a backup first to the local backup server, and then you replicate it to a remote backup server. The question is, are you going to maintain those backups at the remote site in a deduplicated and compressed format, or are you going to maintain them in a non-compressed format? If they're non-compressed, you can recover almost instantaneously by simply pointing the hypervisor at that image. But if you care about disk usage, and you care about the size of the data that you're moving around, you'll probably want to keep your backups in a compressed format consisting of a combination of full and incremental backups as presented in a deduplicated system. There are a lot of issues here, and I'm confident that I've not done justice to the question. So I encourage the questioner to send me an email at the email address on the current slide.
Okay, well, our time's just about up, so I'm going to hand it back over to Abby.
Thank you, Britton, and thank you, Bill. Just wanted to do a quick closing remark and let everyone know that you will get an email in about a week with a link to the recording of this webinar. Also, if you would do us a favor and fill out the few quick survey questions that can be found on your widget bar at the bottom. It's a red box with a check in it. And if you liked what you saw today, WD has another webinar coming up on June 27th at 1 p.m. And if you click on the purple globe at the bottom on your widget bar, you will be able to register for that. So be sure to check out both of those. And just wanted to say thanks again to WD for sponsoring the webinar today. Hope everyone has a great rest of the afternoon.